right? I can take the sheet out, put it back, take the sheet out, put it back. Now I am going to do a small trick. I want to lift it from somewhere else, so I will put a catch. Okay? Kandala? Any nadukku pidichittu pokanam. You have to lift it from the center. You try. Pidichu pokiko. Doesn't come. Come on. Yeah. Where are you? Okay. If you want a catch, I can give you more of a catch. So you are going to lift it by pulling to the center. Oh, that alone came. It doesn't come out. Okay, leave it. Now you try to pull up. Now try to pull it. You are not able to take it out. Why? Anybody? It is pressure. The atmospheric pressure pushes it down. And this is sticking to the table. So it cannot come out. But if I want to take it out, there's an easy method. Now it comes out. Why? Anybody? Think about it. You are allowing air to get in. Now you cannot pull it up. Somebody wants to try pulling? One more fellow? Boys? Anybody? Okay. Right. So, it is the atmospheric pressure, atmospheric column. Vayu undannale. Ee vayuvinte column adunu pidiche endu cheyanu amarthunnu. You follow that? Air pressure. Is it clear, all of you? For air pressure, the formula you have not studied. It is called H rho g. H is the height of atmospheric column, rho is the density of atmospheric column, and g is your acceleration due to gravity. So you have to find out the height of the air column. You have to find out density of air. And g stands for acceleration due to gravity. Okay? We say atmospheric pressure is 76 centimeter of mercury. What is it now? And then 76 centimeter mercury applies a pressure. The same pressure is that of atmosphere. Okay? So if I want to know what is the pressure, I can take 76 centimeter of mercury into density of mercury 13.6 gram per cc into the value of G, which is 981. Then calculate. When you calculate, you will find out the weight acting on this is of the order of kilograms. Few hundreds of kilograms weight. Atrayum kilogram weight in the pressure on I am not able to pull it up at all. Could you understand that? Did you understand fully well? Did you enjoy it?
Hello, I am Dr. Purnima N, Assistant Professor, Department of Physics, St. Paul's College, Kalamassery. With me is Dr. Rajesh Mohan VG, Assistant Professor and Head of the Department of Physics, St. Paul's College. We are here to perform an experiment called the quill tube experiment under the guidance of Dr. T.R. Ananthakrishnan, who was former Head of the Department of Physics, St. Paul's College. This is a very simple experiment to find the atmospheric pressure. The basic principle on which this experiment works is Boyle's law. We all know that for a constant mass of gas, volume is inversely proportional to pressure, or in other terms, PV is a constant. For this experiment, we require a capillary tube, some mercury, a meter scale to take the readings, a knife edge, and some tape or wax to seal one end of the capillary tube. So before proceeding with the experiment, you take a capillary tube like this of uniform bore size, and you fill some mercury in this tube and seal one end of the tube. You see that an air column gets trapped between the closed end and the mercury pellet that was inserted. And now we are performing this experiment in 5 different configurations, with the open end of the capillary tube up, with the open end down, and the capillary tube inclined with the open end up and down and in the horizontal position. And we are looking at the pressure that is experienced by the air column trapped between the closed end and the mercury pellet. And for that particular air column, we are here to apply Boyle's law. And we see that the pressure experienced by the air column in the first case, that is with the open end up, would be the sum of pressures due to atmosphere and the pressure exerted by the mercury pellet. Whereas in the second configuration, you see that the pressure experienced by the air column would be a difference of atmospheric pressure and the pressure exerted by the mercury pellet. So when you apply Boyle's law, pressure times volume is a constant, you get this equation. Here you see that there is no area component written here, because in all these configurations we are using the same capillary tube and area is a constant. So it's just enough to measure the length of the trapped air column. And in the first case, P times V would be like this, H plus H1 times L1, and in the second case, the P times V term would be like this, H minus H times L2, where you see that H1 is the length of the mercury pellet, L1 is the length of the trapped air column in the first case, and H2 and L2 are the corresponding terms in the second case. And while doing the experiment, all you need to do is you measure the values of H1, L1, H2 and L2. You substitute in this equation and find the atmospheric pressure. Similar is the case with these 3 configurations. In all these 3 configurations, you need to find out the pressure experienced by this air column, and in this case with the open end up, when the tube is inclined, the term would be like this, H plus H3 times L3, and in this case when the open end is down, the pressure times volume term would be like this. And from here again, when you measure H3, L3, H4 and L4, you can compute the value of atmospheric pressure. And in this case, you see that the pressure experienced by the air column would be just the atmospheric pressure alone. So from these 5 configurations, it is possible to calculate the value of atmospheric pressure. After performing the experiment with our experimental setup, we have obtained these set of readings. You can see the 5 cases as I mentioned just before. The capillary tube in the vertical position with the open end up and down, capillary tube in the inclined position with the open end up and down, and capillary tube in the horizontal position. The formulas that have been used for computing the value of atmospheric pressure have been given here, and the values computed for atmospheric pressure matches with the standard value of 76 centimeters of mercury. So this is a very simple experiment to compute the value of atmospheric pressure. Thank you.